Before we start climbing the dimensional ladder, I need to tell you something that almost nobody mentions. There's a mistake in how nearly every popular explanation presents this stuff. They make it sound like dimensions are places you visit, like different floors in a building. That's not even close to the truth. And if you carry that misunderstanding with you, none of what I'm about to share will actually click. Dimensions aren't places. They're degrees of freedom. They're directions you can move in. They're independent axes of possibility. I'll show you exactly what that means, but first, we have to start at the very bottom. Imagine something that doesn't take up any space at all. Not small, not tiny, zero size. A point. That's it. No length, no width, no height, just position. That's a zero-dimensional object. You might be wondering how something can exist without taking up space. Fair question. Because in the world you experience every day, everything takes up space. But here's the thing. A point doesn't exist in the way a rock exists. It's a concept, a location, a coordinate. If you could shrink yourself down infinitely small, you'd find that a zero-dimensional point has literally nothing inside it. No structure, no movement, no information. Just existence as pure location. Think about what that means. In a zero-dimensional world, there's nowhere to go, nothing to do, no change, no time, just pure static being. It's the ultimate simplicity. And yet, from this simplest of all starting points, we can build the entire complexity of 11-dimensional reality. But here's where it gets interesting. What happens if you take that point and you move it? You get a line. That's the first dimension, length. A one-dimensional world is a line. And in that world, there's only one way to move, forward or backward. That's it. If you were a one-dimensional creature living on that line, your entire existence would be a sequence of positions along a single axis. You could pass other creatures, or they could pass you, but you could never go around them. You could never see what's beside you, because there is no beside. There's only ahead and behind. Think about how limiting that would feel. Your whole universe is a line. Everything that ever happens along that one axis. You could have a civilization, wars, love stories, empires rising and falling, all compressed onto a single mathematical line. And yet, from the perspective of a zero-dimensional point, this is mind-blowing. A point can't even imagine movement. It just is. But in one dimension, suddenly there's change. There's time in the sense of sequence. There's possibility. Now take that line and move it perpendicular to itself. You get a plane, a flat surface with length and width but no height. That's the second dimension. This is where things start to get relatable, because you see two-dimensional representations of the world every single day. Your screen right now is essentially a two-dimensional surface displaying images that trick your brain into seeing three dimensions. A drawing on a piece of paper is two-dimensional. A shadow is two-dimensional. But imagine actually living in two dimensions. Imagine being a flat creature on a flat plane. You could move forward, backward, left, and right, but you could never move up or down. You could never lift yourself off the surface, and the shapes around you would look completely different from how you imagine them now. Here's a mind bender. If you were a two-dimensional being looking at a circle passing through your world, you wouldn't see a circle. You'd see a point that grows into a line segment, reaches a maximum length, then shrinks back to a point and disappears. Because from your flat perspective, you can only perceive cross-sections of things that exist in higher dimensions. There's a brilliant book called Flatland by Edwin Abbott, written way back in 1884, that explores exactly this scenario. It's about a square who lives in a two-dimensional world and gets visited by a sphere from the third dimension. The sphere tries to explain the third dimension to the square, but the square literally can't comprehend it. To the square, the sphere appears as a circle that changes size as it passes through the flat plane. The square thinks the sphere is a magician at best, a fraud at worst. You know what the crazy part is? That's exactly what's happening to you right now, but in reverse. You're a three-dimensional being perceiving a four-dimensional universe, and you're only seeing cross-sections of reality. Higher dimensional objects and beings would appear to you as weird, shape-shifting three-dimensional phenomena that seem to defy the laws of physics. You'd think they were magic, or aliens, or ghosts, but they'd just be operating in directions you can't perceive. For now, stay with me in 2 dimensions. Think about what a 2-dimensional doctor could do. If a flat person had an internal injury, a 2-dimensional surgeon would have to cut through their skin to reach it, right? Because there's no way to go over or under the skin. Those directions don't exist. But a 3-dimensional being could reach right into that flat person's body without breaking the skin at all. We could perform surgery from a direction they can't even perceive. We could remove their heart and they'd have no idea how we did it. To them, it would look like magic. Keep that thought in your back pocket. We're going to come back to it. Because when we get to the higher dimensions, you'll realize that what seems impossible from your current perspective might be trivial from a higher one. Take that flat plane and move it perpendicular to itself. Now you've got length, width, and height. That's the 3rd dimension, the world you think you live in. This is your comfort zone. This is where you eat, sleep, work, love, and exist. You can move in 3 independent directions. You can go around things, you can perceive depth, you understand volume, you can hold objects in your hands and feel their solidity. But here's what nobody tells you. You don't actually see 3 dimensions. Your eyes capture 2-dimensional images, and your brain reconstructs a 3-dimensional model of the world based on parallax, lighting, shadows, and your previous experience. The 3-dimensional reality you believe in is a simulation running inside your skull. Your brain is a virtual reality headset that evolved to help you survive and reproduce, not to show you ultimate truth. Think about that. The world you experience isn't the world itself. It's a user interface, a simplified representation of a much more complex reality. The colors you see don't exist outside your head. They're your brain's interpretation of different wavelengths of light. The solidity you feel when you touch a table isn't because the table is solid. It's because the electrons in your hand are repelling the electrons in the table through electromagnetic force. At the atomic level, everything is almost entirely empty space. So the 3-dimensional world you're so certain about, it's already an illusion. A very convincing illusion, but an illusion nonetheless. And that's before we even get to the fact that the 3rd dimension isn't even the whole story of your everyday existence. Because there's another dimension you're moving through every single moment. One that's so fundamental you barely even think about it as a dimension at all. Time. The 4th dimension. You've probably heard this before. Einstein told us over a century ago that space and time aren't separate things. They're 2 sides of the same coin, space-time. We live in a 4-dimensional fabric where the 3 dimensions of space and 1 dimension of time are woven together into a single, flexible structure that can be stretched and warped by mass and energy. But what does that actually mean? Think about it this way. Right now, you're at a specific location in 3-dimensional space, but you're also at a specific location in time. If you want to meet someone, you can't just tell them where. You have to tell them when. Where and when are equally important coordinates. And Einstein showed that there's no universal now that everyone agrees on. Time flows differently depending on how fast you're moving and how close you are to massive objects. A clock on a satellite orbiting Earth ticks slightly faster than a clock on the ground. A clock on a rocket traveling near the speed of light would tick much slower. Now here's the part that will rewire your brain. You, as a complete entity, are a 4-dimensional object. Your 3-dimensional body right now is just a cross-section, a slice, of the real you. The real you stretches backward in time through every moment you've ever lived, all the way back to your birth, and forward through every moment you will live until your death. You're like a long worm extruded through space-time, with one end at your conception and the other at your death. And the you that's watching this right now, that's just the 3-dimensional cross-section of that worm at this particular moment in time. You're not seeing your whole self, you're seeing a slice. This changes everything, because it means that past you and future you aren't memories or predictions. They're real. They exist, just in different parts of the 4th dimension, the same way different parts of your body exist in different parts of the 3rd dimension. Your left hand isn't less real than your right hand just because it's in a different location. And your 10-year-old self isn't less real than your current self just because they're in a different time. But wait, you might be thinking, if time is just another dimension, why can't we move through it the way we move through space? Why can't we go backward in time the way we can walk backward down a hallway? Why is there an arrow of time that points from past to future? That's an excellent question, and the answer is one of the deepest mysteries in physics. We don't fully know, but we have clues. The second law of thermodynamics tells us that entropy, the amount of disorder in a system, always increases over time. The universe started in a state of incredibly low entropy at the Big Bang, and it's been getting more disordered ever since. This increase in entropy is what gives time its direction. Eggs break, they don't unbreak. Ice melts, it doesn't unmelt. We remember the past, not the future. But here's the thing. The fundamental laws of physics don't care about the direction of time. They work just as well backward as forward. If you watched a video of two billiard balls colliding, you couldn't tell if the video was playing forward or backward. The arrow of time only appears when you're dealing with large numbers of particles, with systems moving from order to disorder. And those clues point to something astonishing about the dimensions above the fourth. Because if time is just another dimension, and the arrow of time is a statistical effect rather than a fundamental law, then from a higher dimensional perspective, the past and future would all be visible at once. A being in the fifth dimension could look at your entire four-dimensional life the way you look at a painting. All of it there, simultaneously, past and future existing together in a single eternal now. Because here's the thing, up to this point, everything I've told you is relatively mainstream. 0 dimensions, 1 dimension, 2 dimensions, 3 dimensions, 4 dimensions of space-time. Every working physicist agrees on this. This is the territory of general relativity, tested and verified to absurd precision. We've measured the warping of space-time around Earth with satellites. We've detected gravitational waves rippling through the four-dimensional fabric from colliding black holes billions of light years away. This isn't speculation, this is fact. But now we're about to cross the border. We're leaving the land of confirmed experimental fact and entering the realm of the most ambitious, most mathematically beautiful, most controversial theory in all of physics, string theory. And to understand why string theory demands extra dimensions, we have to take a detour into the quantum world, because the problem string theory was invented to solve is the biggest problem in all of modern physics. You see, we have two incredibly successful theories that describe how the universe works. One is general relativity, which describes gravity and the very large, stars, galaxies, black holes, the entire cosmos. The other is quantum mechanics, which describes the other three fundamental forces: electromagnetism, the strong nuclear force, and the weak nuclear force, and the very small, atoms, subatomic particles, the weird world inside the nucleus. Both theories work perfectly in their own domains. General relativity has never failed a test. Quantum mechanics is the most precisely tested theory in human history, accurate to 12 decimal places in some experiments. The computer you're watching this on only exists because we understand quantum mechanics well enough to build transistors. But here's the problem. When you try to put them together, they break. They give you nonsense answers, infinites that can't be canceled out, mathematical contradictions that mean our understanding of reality is fundamentally incomplete. This isn't a minor disagreement. This is a crisis at the heart of physics, because there are places in the universe where both theories are required to describe what's happening. The center of a black hole, the first moment of the Big Bang. In those extreme conditions, we literally have no idea what's going on. Our equations just say infinity and stop working. For decades, physicists have been searching for a theory of everything, a single mathematical framework that can describe all four fundamental forces, all of reality, from the smallest quantum scale to the largest cosmic scale. And the most promising candidate we've ever found is string theory. But before we dive into string theory itself, I need you to understand just how weird the quantum world is. Because quantum mechanics isn't just a set of equations, it's a fundamental challenge to everything you think you know about reality. Let's start with the double-slit experiment. This is the most famous experiment in quantum physics, and it's been replicated thousands of times. Here's what happens. You fire particles, electrons usually, at a barrier with two slits in it. On the other side of the barrier is a screen that detects where the electrons land. If electrons were tiny little balls, you'd expect them to go through one slit or the other and create two bands on the detector screen. That's what common sense tells you should happen. But that's not what happens. Instead, you get an interference pattern, a series of light and dark bands. The kind of pattern you get when waves pass through two slits and interfere with each other, peaks adding to peaks, troughs canceling out peaks. So electrons behave like waves? But wait, when you put a detector at the slits to see which slit each electron actually goes through, the interference pattern disappears. Now you get two bands, just like the particles are tiny little balls after all. The act of measurement changes the behavior of the particle, as if the electron knows it's being watched and decides to act differently. And it gets weirder. The electron doesn't just go through one slit or the other when you're not looking. It goes through both slits at the same time. It exists in a superposition of states, simultaneously taking every possible path from the source to the detector. Only when it's measured does this superposition collapse into a single definite state. Then there's quantum entanglement. Einstein called this spooky action at a distance, and he hated it. Here's how it works. You can create two particles that are entangled, meaning their properties are correlated in such a way that measuring one instantly determines the state of the other, no matter how far apart they are. You could separate them by light years, measure one, and the other would instantly take on a definite state. Instantly, faster than light, which would seem to violate relativity. But somehow it doesn't, because you can't use this to send information faster than light. The results are random, but the correlation is real, and it's been experimentally verified over and over again. What does this mean? It means that at the quantum level, reality isn't local. Things can be connected across vast distances in ways that don't make sense in our four-dimensional space-time. It means that the properties of particles aren't definite until they're measured. It means that our common sense notions of how the world works don't apply at the smallest scales. And this is the world that string theory has to describe, a world of superposition and entanglement and wave-particle duality, a world that seems to operate by rules that are completely alien to our everyday experience. Here's the core idea of string theory. For as long as we've been doing particle physics, we've assumed that the fundamental building blocks of reality are zero-dimensional points, tiny, structureless particles. Quarks, electrons, photons, all of them, points with no size, no internal structure. String theory says that's wrong. But the story of how we got here is fascinating, and it starts with an accident. Back in 1968, a physicist named Gabriele Veneziano was working at CERN, trying to understand the strong nuclear force, the force that holds atomic nuclei together. He was flipping through an old math book when he noticed that a 200-year-old formula, written by the mathematician Leonhard Euler, seemed to perfectly describe the patterns he was seeing in particle collision data. Veneziano didn't know why this formula worked. He just knew it did. Then a few years later, other physicists, Leonard Susskind, Holger Nielsen, and Yoichiro Nambu, realized something. If you modeled particles not as points, but as tiny, vibrating strings, Euler's formula emerged naturally from the mathematics. The formula wasn't just a random coincidence, it was describing the behavior of strings. And that's how string theory was born, by accident, from a 200-year-old math formula that someone happened to notice fit some experimental data. At first, people thought string theory was just a theory of the strong nuclear force. But then quantum chromodynamics came along and described the strong force much better, and string theory fell out of favor. Most physicists abandoned it, but a few kept going, and they noticed something strange. String theory kept predicting a particle that didn't make sense, a massless particle with spin 2. Nobody knew what it was, until someone realized that's exactly what a graviton would look like, the hypothetical particle that carries the force of gravity. Suddenly, string theory wasn't just a theory of the strong force, it was a theory that included gravity, and that changed everything. String theory says that at the smallest possible scale, far smaller than anything we can currently detect, the fundamental constituents of the universe aren't points at all. They're tiny, one-dimensional vibrating strings. Think about a guitar string. Pluck it one way, you get a certain note. Pluck it another way, you get a different note. Same string, different vibration, different sound. In string theory, the same principle applies to reality itself. The same fundamental string, vibrating in different patterns, appears to us as different particles. One vibration pattern is an electron, another is a quark, another is a photon, another, crucially, is a graviton, the hypothetical particle that carries the force of gravity. And that's the magic, because when you describe particles as vibrating strings instead of point particles, the mathematics suddenly works. General relativity and quantum mechanics stop fighting. The infinities disappear. For the first time, we have a single mathematical framework that can, in principle, describe everything. But there's a catch. Actually, catch is too gentle a word. There's a bombshell. The mathematics of string theory only works if the universe has more dimensions than the four we experience. A lot more. How many more? Well, the original versions of string theory that emerged in the 1970s and 1980s required 26 dimensions. That's right, 26. The early bosonic string theory needed 26 space-time dimensions to be mathematically consistent. But this theory had problems. It only described bosons, the force-carrying particles, and it didn't include fermions, the matter particles. And it predicted a particle called a tachyon that would travel faster than light, which didn't make sense. Then came superstring theory, which incorporated supersymmetry, the idea that every particle we know has a heavier superpartner particle, and that brought the number down to 10. Supersymmetry paired each boson with a fermion and vice versa, eliminated the tachyon problem, and gave us a theory that could describe both matter and forces in 10 dimensions. Now, supersymmetry is a whole fascinating topic in its own right. The idea is that the universe has a hidden symmetry that relates particles of different spins. For every matter particle, fermions like electrons and quarks, there's a corresponding force particle, a boson. And for every force particle, there's a corresponding matter particle. The electron would have a superpartner called the selectron. The photon would have a superpartner called the photino. The Higgs boson would have the Higgsino. None of these superpartner particles have been observed yet, which is one of the reasons some physicists are skeptical of supersymmetry. But the theory is so mathematically elegant, and it solves so many problems in particle physics, that many physicists believe it must be true. They think the superpartners are just too heavy to have been detected by our current accelerators. The Large Hadron Collider might be powerful enough to find them, or we might need an even bigger machine. Supersymmetry also helps explain why gravity is so weak compared to the other forces. In supersymmetric theories, the strengths of the three quantum forces, electromagnetism, strong, and weak, converge at extremely high energies, suggesting they're all different aspects of a single unified force. This grand unification is something physicists have been chasing for decades, and supersymmetry makes it work mathematically. 10 dimensions. That's 6 extra spatial dimensions beyond the 3 we experience every day, plus time. You're probably wondering the same thing every single person wonders when they first hear this. If there are 6 extra dimensions, where are they? Why can't we see them? Why can't we move through them? Great question. And the answer is simultaneously elegant and mind-bending. The extra dimensions are compactified. They're curled up. They're tiny. How tiny? So small that they're below the scale where we could possibly detect them with current technology. We're talking about the Planck scale, about 10 to the power of negative 35 meters. That's a decimal point followed by 34 zeros and a 1, a trillionth of a trillionth of the diameter of a proton. To give you a sense of how absurdly small that is, if you blew up an atom to the size of the solar system, one of these compactified dimensions would be about the size of a tree. That's how far below our current ability to probe these dimensions are. The Large Hadron Collider, the most powerful machine humanity has ever built, can probe down to about 10 to the power of negative 19 meters. That's still 16 orders of magnitude away from the Planck scale. We're like ants trying to understand the shape of the Earth by crawling around on a single grain of sand. So everywhere in space, at every single point, right here where you're sitting, there are 6 extra spatial dimensions curled up into tiny, intricate shapes. You're moving through them constantly. Every particle in your body is vibrating through them, but they're so small that you don't notice. You can't reach into them. You can't point in their direction. They're everywhere and nowhere at once. And here's the kicker. The shape of these curled up dimensions isn't just a detail. It determines everything. The geometry of these compactified dimensions, what mathematicians call Calabi-Yau manifolds, determines the vibration patterns of the strings, and those vibration patterns determine what particles exist, what their masses are, how the forces work, even whether complex structures like atoms and stars and life can exist. The shape of the hidden dimensions is the blueprint for our universe. Change the shape, and you change everything. A slightly different Calabi-Yau geometry, and electrons might be too heavy to form atoms, or the strong nuclear force might be too weak to hold nuclei together, or gravity might be so strong that the universe would have collapsed back in on itself moments after the Big Bang. We live in a universe where the hidden dimensions have exactly the right shape to allow for complexity, for stars, for planets, for life. That's either an incredible coincidence, or there's a deeper reason, perhaps the anthropic principle, which says that we can only observe a universe that's compatible with our existence. Or perhaps there are many universes with many different shapes, and we just happen to be in one that works. This is the string theory landscape, the idea that there are 10 to the power of 500 different possible universes, each with different physical laws, and we live in one that's just right for life. Some physicists hate this idea. They think it's giving up, that it's not science because you can't test it. Others think it's the natural conclusion of the mathematics, and that we need to accept that our universe isn't special, just rare. I find this both humbling and thrilling. Humbling because it means our universe is just one possibility among an unimaginably vast number. Thrilling because it means reality is far larger and more diverse than anything we can currently observe. But then something happened. Something that no one saw coming. For years, there were actually 5 different versions of superstring theory, all requiring 10 dimensions, all mathematically consistent, and no one knew which one, if any, described our actual universe. There was Type 1, Type 2a, Type 2b, heterotic SO32, and heterotic E8 times E8. 5 different theories of everything, and they all looked equally valid. It was an embarrassment of riches. Physicists argued about which one was correct for years. Conferences would turn into shouting matches. Careers were made and broken defending one version against another. It seemed like string theory was going to fragment into a dozen different competing theories, and the dream of a unified description of reality would slip away. Then, in the mid-1990s, a physicist named Edward Witten made a discovery that shook the entire field. He showed that these 5 theories weren't actually competing. They were different ways of looking at the same thing, different approximations of a deeper, more fundamental theory. And that deeper theory required not 10 dimensions, but 11. M-theory was born. The M has never been officially defined. Some say it stands for membrane, some say master, some say magic, some say mystery. Witten himself has joked that it stands for murky, because we understand it so poorly. But whatever the M stands for, the theory is breathtaking in its scope. In M-theory, the fundamental objects of reality aren't just one-dimensional strings. They can also be 2-dimensional membranes, 3-dimensional blobs, and higher-dimensional objects called p-branes, where p stands for the number of spatial dimensions the object occupies. A point particle is a 0 brane, a string is a 1 brane, a membrane is a 2 brane, and so on, up through the dimensions. These branes can stretch, vibrate, collide, and interact in complex ways. And in the right circumstances, a brane can grow to enormous size, even the size of an entire universe, which leads to one of the most mind-blowing ideas to come out of M-theory. Our entire 4-dimensional universe might be a 3-brane, a 3-dimensional membrane, floating in a higher dimensional space called the bulk. Think about that for a second. Everything you've ever known, every star you've ever seen, every galaxy in the observable universe, all of it might be stuck to the surface of a 3-dimensional membrane, like soap scum on the surface of a pond. And there could be other branes, other universes, floating through the bulk alongside ours. Some might be just a tiny distance away from ours in the higher dimensions, closer than your own skin. But you can't see them, can't touch them, can't detect them, because the particles that make up your body are stuck to our brain. Most forces are stuck to the brain too. Electromagnetism, the strong nuclear force, the weak nuclear force, they can't leave our 3-dimensional membrane. That's why you can't see or touch the other branes. The photons that carry light can't travel through the bulk. They can only move along our brain. But gravity is different. Gravity is the geometry of space-time itself, and it can leak into the extra dimensions. In fact, some physicists think that gravity is so weak compared to the other forces, precisely because most of it is leaking away into the higher dimensions. The other three forces are confined to our brain and are therefore strong. Gravity spreads out through all 11 dimensions and is therefore diluted, appearing weak to us in our four-dimensional world. This actually gives us a possible way to test for extra dimensions. If gravity is leaking into extra dimensions, then at very small distances, gravity should be stronger than the inverse square law predicts, because the gravity hasn't had a chance to spread out into the extra dimensions yet. Physicists have been doing extremely precise experiments to measure gravity at sub-millimeter scales, looking for deviations from the inverse square law. So far, they haven't found any, but they're getting closer, probing smaller and smaller distances. If they do find a deviation, that would be the first experimental evidence for extra dimensions, and it would change everything. This is brain cosmology, and it leads to some astonishing possibilities. Sometimes these brains could collide, and a collision between two brains would release so much energy that it would look exactly like a Big Bang from the perspective of someone inside one of those brains. The Big Bang, in this view, wasn't the beginning of everything. It was a collision event in a much larger, much older reality. And the cycle of collisions could repeat endlessly. Brains drift apart, then drift back together, collide again, creating new Big Bangs, new universes, over and over for eternity. Now, we're about to climb through dimensions 5 through 11, and I need to warn you, this is where your intuition is going to start screaming that this can't be right. That's normal. Your brain evolved to navigate 3 spatial dimensions and 1 time dimension. It has no hardware for visualizing 11. So don't feel bad if you can't picture this stuff. Nobody can. Even the physicists who work on this every day can't truly visualize 11 dimensions. They use mathematics as a crutch, analogies as guide ropes. So as we go, I'm going to give you the best analogies I've found, the ones that actually helped me wrap my head around this. And I want you to remember something. Understanding isn't the same as visualizing. You can understand that something is true without being able to form a mental picture of it. You understand that the earth is round, even though you can't see the curvature from where you're standing. This is the same thing, just bigger. We've covered 0 through 4. Let's go to 5, the 5th dimension. If the 4th dimension is time as a single line, past, present, future, stretched out in one direction, then the 5th dimension is the first dimension of possibility. It's the dimension of parallel timelines. In the 5th dimension, every possible outcome of every event exists. Every choice you could have made, every random quantum event that could have turned out differently, branches off into its own timeline. The 5th dimension is the landscape of all possible histories that could have resulted from the initial conditions of our universe. Think back to the 2-dimensional plane. A line of time, the 4th dimension, moving perpendicular to itself, creates a plane of possible timelines, the 5th dimension. So from your current position in space-time, there's a version of you that took a different job, married a different person, never watched this video. There's a version of you that became a billionaire, a version that became homeless, a version that died in a car accident last year, a version that discovered a cure for cancer. All of those versions exist, just in different parts of the 5th dimension. And just like a 3-dimensional being could reach into a 2-dimensional world without breaking the skin, a 5-dimensional being could reach into our 4-dimensional space-time in ways that would look like miracles to us. They could jump between timelines. They could visit a version of your life where you made different choices. They could see how a single decision ripples outward through history. They could reach into your past and change something, creating a new branch in the 5th dimension. But here's what's even more interesting. In quantum mechanics, we have this thing called the uncertainty principle. Particles don't have definite properties until they're measured. They exist in a superposition of states. And the famous many worlds interpretation, first proposed by Hugh Everett in 1957, says that when a measurement happens, the universe doesn't choose one outcome, it branches. All outcomes happen, each in their own separate world. Those separate worlds, they're separated along the 5th dimension. The fifth dimension is where quantum possibility becomes physical reality. Every time a quantum event could go two ways, the universe branches in the fifth dimension, creating separate worlds where each outcome is real. And this connects back to the weirdness of quantum mechanics we talked about earlier. The double slit experiment, where the electron seems to go through both slits at once. In the many worlds view, it does go through both slits, but in different worlds that exist in the fifth dimension. The interference pattern we see is the subtle influence of those other worlds on our own. Quantum entanglement, where particles are connected across vast distances. In the fifth dimensional view, the particles aren't separate at all. They're two ends of a single five-dimensional object, and we're only seeing three-dimensional cross-sections of it in our world. That's why measuring one instantly affects the other. They're the same thing from a higher dimensional perspective. Now take that five-dimensional plane of possible timelines and move it perpendicular to itself, the sixth dimension. If the fifth dimension is all possible timelines that could arise from our universe's initial conditions, from the Big Bang as we know it, then the sixth dimension is the space of all possible timelines that could arise from all possible initial conditions. Let me say that again, because it's huge. In the fifth dimension, you have every possible version of our universe, every possible history, every possible future, but all starting from the same Big Bang, with the same physical constants, the same laws of physics, the same Calabi-Yau shape curled up in the extra dimensions. In the sixth dimension, you have every possible universe. Universes where gravity is stronger, universes where the electron is heavier, universes where the strong nuclear force is a little weaker and atoms can't form, universes where stars burn hotter and die younger, universes where life evolved completely differently or not at all, universes with different numbers of large spatial dimensions, universes where time flows backward, universes where the fundamental forces have different strengths entirely. The sixth dimension is the landscape of all possible universes with all possible physical laws, all possible starting conditions, all possible histories and futures. And here's the part that connects back to string theory. Remember those Calabi-Yau shapes I mentioned? The curled up extra dimensions whose geometry determines the laws of physics? Each different shape corresponds to a different point in the sixth dimension. Each shape produces a different universe with different constants, different forces, different particles. String theory suggests there are something like 10 to the power of 500 possible Calabi-Yau shapes. That's a 1 followed by 500 zeros. More possible universe configurations than there are atoms in our observable universe. Each one a different reality, existing somewhere in the sixth dimension. Most of them are dead, empty, boring. No stars, no planets, no complexity. But a tiny fraction, still an unimaginably vast number, have the right conditions for complexity, for stars, for planets, for life. We happen to live in one of the good ones. And from the sixth dimension, you could jump between these universes. You could visit a universe where the speed of light is different, where water flows uphill, where dinosaurs never went extinct. You could see all possible realities, all possible universes, laid out before you like a map. Now move that sixth-dimensional space perpendicular to itself, the seventh dimension. If the sixth dimension is all possible universes with all possible laws and histories, then the seventh dimension is where things start to get truly abstract. Because in the seventh dimension, you're not just dealing with universes that follow the same kind of physical framework as ours. You're dealing with universes where the fundamental rules of existence itself are different. In our framework, we have things like quantum mechanics, relativity, causality, logic. In the seventh dimension, there could be realities where none of those things apply. Realities where effects precede causes. Realities where 2 + 2 = 5. Realities where existence and non-existence aren't binary opposites. Realities that follow mathematical systems we haven't even discovered yet, or that don't follow mathematics at all. The seventh dimension is the space of all possible frameworks of reality, all possible ways that existence could work. Not just different rules within a framework, but different frameworks entirely. You can see why this gets hard to talk about. We don't have words for realities that don't follow our logic. Our language evolved to describe our corner of existence. It breaks down when we try to describe the rest. But that's okay. You don't need to be able to imagine a reality without causality to understand that mathematically, such a space is the next logical step in the dimensional hierarchy. Each dimension encompasses all of the previous ones and adds a new degree of freedom. The seventh dimension adds the freedom of entirely different existential frameworks. Take that and move it perpendicular, the eighth dimension. Now we're talking about different systems of frameworks. If the seventh dimension is all possible frameworks, the eighth dimension is all possible relationships between frameworks, all possible transitions, all possible connections, all possible ways that different fundamental realities could interact or transform into each other. This is where the brain cosmology ideas from M-theory start to become relevant. In brain cosmology, our entire four-dimensional universe is a three-brain floating in a higher dimensional space called the bulk. And there could be other brains, other universes, floating through this bulk too. Sometimes these brains could collide, and a collision between two brains would release so much energy that it would look exactly like a Big Bang from the perspective of someone inside one of those brains. The Big Bang, in this view, wasn't the beginning of everything. It was a collision event in a much larger, much older reality. And the eighth dimension is the space where these kinds of interactions between fundamentally different frameworks can happen. It's the dimension of cosmic collisions, of universe births, of reality transforming into reality. It's where the rules of one framework can give birth to the rules of another, where entire new realities can emerge from the interaction of older ones. Keep going. Move perpendicular again, the ninth dimension. If the eighth dimension is about interactions between frameworks, the ninth dimension is about the laws that govern those interactions, the meta-laws, the rules that determine how frameworks can change, how they can connect, what transformations are possible and what aren't. In the ninth dimension, you're looking at the structure that makes the eighth dimension possible, the underlying logic that allows different realities to interact, to transform, to give birth to each other. It's the dimension of the patterns that patterns follow, the laws that laws obey. This is getting extremely abstract, I know, but stay with me. We're almost there. Move perpendicular one more time, the 10th dimension. In the original 10-dimensional superstring theory, this is where the story ends. The 10th dimension encompasses everything. Every possible universe, every possible framework, every possible interaction, every possible history, every possible future, every possible everything. In the 10th dimension, there's nowhere left to go. Every possibility is already contained within it. There's no new direction to move perpendicular to, because any direction you could possibly imagine is already part of the 10-dimensional structure. The 10th dimension is the everything, the all, the complete set of all possible realities, all possible states, all possible existences. In a very real sense, the 10th dimension is infinity made manifest. But then M-theory came along and said, wait, there's one more, the 11th dimension. The 11th dimension is the unifying dimension. It's the dimension that reveals that the 5 different 10-dimensional string theories are actually the same thing, seen from different angles. In M-theory, the 11th dimension is where the fundamental nature of reality lives. It's the dimension where strings can stretch into membranes, where membranes can grow to the size of entire universes, where the fabric of existence itself takes on its most fundamental form. The 11th dimension is the meta-reality that contains all possible 10-dimensional realities. It's the canvas on which the entire string theory landscape is painted. And here's the most beautiful part. In the 11th dimension, everything is one. All the separate brains, all the separate universes, all the separate timelines, all the separate possibilities, they're all connected, all part of a single, unified, 11-dimensional structure. The separation we perceive between things, between people, between moments, between universes, it's an illusion, a consequence of our limited 3-dimensional perspective. In the full 11-dimensional picture of reality described by M-theory, everything is connected, everything is one. I told you this would change how you see the world. Now, I know what some of you are thinking. You're thinking, this is all just theory. None of this has been proven. It's just math. It's just speculation. And you're right, sort of. It is true that we don't have experimental confirmation of string theory or M theory. The energy scales required to probe these dimensions directly are way beyond anything we can currently achieve. The Large Hadron Collider, the most powerful particle accelerator ever built, would need to be the size of the Milky Way galaxy to reach the Planck scale where these effects become obvious. But here's what the critics often miss. String theory isn't just a random idea someone pulled out of thin air. It's a mathematical framework that emerged naturally from attempts to solve real problems in physics, and it has passed every theoretical test we've thrown at it. It produces general relativity automatically. It produces quantum mechanics automatically. It explains things that no other theory can explain, and there have been tantalizing hints. When physicists use the ADS-CFT correspondence, a mathematical tool that comes directly out of string theory, to solve problems in other fields, it works. It gives correct answers about things we can test, like the behavior of quark-gluon plasmas in heavy ion collisions. A theory that's completely wrong doesn't accidentally give you the right answers to completely unrelated problems. String theory has also led to deep insights in pure mathematics. Physicists using string theory have made discoveries about Calabi-Yau manifolds and mirror symmetry that mathematicians had missed for decades. When a physical theory starts teaching mathematicians new mathematics, that's usually a sign that it's onto something real. But let's be honest, maybe string theory is wrong. Maybe M theory is a beautiful dead end. Maybe the universe really only has 4 dimensions, and the extra dimensions are just mathematical artifacts. Maybe we'll never find experimental evidence one way or the other. But here's the thing. Even if that turns out to be true, the journey we just took isn't worthless. Because thinking in higher dimensions changes how you think about reality. It teaches you that your perspective is limited, that what you see isn't all there is, that the world is bigger, stranger, more wonderful than your senses can detect. And honestly, I think that's the most important lesson of all, because you don't need 11 dimensions to know that your perspective is limited. You're a human being with human senses, human biases, human limitations. You see a tiny sliver of the electromagnetic spectrum. You hear a tiny range of sound frequencies. You perceive time flowing in one direction at one particular speed. You experience a 3-dimensional slice of a reality that could be far larger. And that's true even if string theory is completely wrong. But what if it's right? What if you really are an 11-dimensional being, currently perceiving only a tiny 3-dimensional cross-section of your true self? What if the walls that seem to separate you from other people, from the past, from the future, from other possibilities, what if those walls are just artifacts of your limited perspective? What if, at the deepest level of reality, everything is connected? That changes how you live. It changes how you treat other people. It changes how you think about your past and your future. It changes what you think is possible. Because if the 5th dimension is real, then somewhere, the version of you that achieved your wildest dreams is already living that life. And the gap between you and that version of you isn't a gap of ability or worth. It's a gap of dimension. It's a gap of perspective. It's a gap of which vibration pattern you're currently aligned with. And if the 6th dimension is real, then there are universes where you're everything you ever wanted to be. Universes where you made the brave choice, where you took the risk, where you didn't let fear hold you back. And here's the secret nobody tells you. You don't need a spaceship or a portal to reach those versions of reality. You just need to change your vibration. You just need to make different choices. You just need to align yourself with the version of reality you want to experience. Because in a very real way, every choice you make moves you through the dimensions of possibility. Every decision shifts your position in the landscape of what could be. You're a dimensional traveler, and you don't even know it. I spent years thinking this stuff was just abstract mathematics, just physics nerds arguing about things that don't matter. But then I realized something. The question of how many dimensions the universe has isn't just a physics question. It's an existential question. It's a question about who you are, what you're made of, and what's possible for you. If the universe is only 4 dimensions, then you're a finite creature trapped in a linear timeline, hurtling toward death, with limited options and a narrow range of possibility. But if the universe is 11 dimensions, then you're an infinite being having a finite experience. You're a multidimensional entity currently focused on a single three-dimensional slice of your vast, eternal self. You have access to possibilities you can't even imagine. You're connected to everything and everyone in ways you can't currently perceive, and that changes everything. Now, I want to be clear. I'm not saying this gives you permission to ignore your problems. I'm not saying you can just think positive thoughts and manifest $1 million while sitting on your couch. The three-dimensional world you experience is real. It has real consequences. Actions matter. Effort matters. The choices you make in this dimension have real effects on the life you experience. But what I am saying is that the ceiling on what's possible for you is way higher than you've been taught to believe. The limitations you feel aren't built into the fabric of reality. They're built into your perception of reality. They're the walls your three-dimensional mind constructs because it can't see the full 11-dimensional picture. And when you start to understand that, when you start to live from the perspective that you're a multidimensional being with access to infinite possibility, that's when your life changes. That's when you stop accepting the limits other people put on you. That's when you start creating the reality you want, instead of just reacting to the reality you've been given. I remember when this first clicked for me. I was going through a really hard time. I was stuck in a job I hated, in a relationship that wasn't working, in a life that felt small and limited. I felt trapped, like there was no way out, like this was all there was. I'd spend my days going through the motions, feeling like I was just watching my life happen to me rather than living it. I'd lie awake at night wondering if this was really it, if I was just going to keep doing the same things until I died. And then I started thinking about dimensions, about how a two-dimensional creature would feel trapped on its flat plane, not realizing there's a whole third dimension it could move through if it only knew how. About how I might be that two-dimensional creature, not realizing the dimensions of possibility that are available to me. I started thinking about the fifth dimension, about all the possible versions of my life that exist, about the version of me that was happy, that was fulfilled, that was doing work that mattered. And I realized that version of me wasn't some distant fantasy. It was real. It existed, just in a different part of the dimensional landscape. And the gap between that version of me and the version I was currently experiencing wasn't a gap of worth or ability. It was a gap of choices. It was a gap of vibration. It was a gap of which path I was choosing to walk down. And something shifted. I realized that the feeling of being trapped wasn't coming from reality itself. It was coming from my limited perspective. I had more options than I could see, more directions I could move, more possibilities available to me than my three-dimensional mind was perceiving. I quit that job. I ended that relationship. I started making different choices, and my life started to change in ways I couldn't have predicted. It wasn't magic, it was work. But the work got easier when I stopped believing that my current circumstances were all there was. When I started living from the understanding that I'm a multi-dimensional being with access to infinite possibility. I'm not saying understanding dimensions will solve all your problems. I still have hard days. I still struggle with self-doubt and fear and uncertainty. But those feelings have less power over me now, because I know they're just three-dimensional reactions to a three-dimensional slice of a much larger reality. So where does this leave us? Really, it all comes down to this. Reality is not what it seems. The dimensions you experience are a tiny fraction of the dimensions that exist. From a zero-dimensional point of pure position, through the lines and planes and volumes of everyday space, through the fourth dimension of time that weaves it all into space-time, through the fifth dimension of parallel timelines where every possibility exists, through the sixth dimension of all possible universes, on up through the abstract higher dimensions of frameworks and interactions and meta-laws, all the way to the 10th dimension of everything and the 11th dimension that unifies it all. This is the landscape of existence as described by our best current physics. You are not just a body moving through space and time. You are a pattern of energy vibrating across multiple dimensions, a ripple in the 11-dimensional fabric of reality, connected to everything that ever was, is, or will be. And the most incredible part, you get to choose what pattern you vibrate in. You get to choose which slice of reality you experience. You get to choose which version of your life you align with. You have more power than you know, more possibility than you can imagine, more dimensions to your being than your senses can detect. So don't let anyone tell you what's impossible. Don't let the limits of three-dimensional thinking box you in. The universe is bigger, stranger, and more wonderful than any of us can fully grasp. And you are made of that universe. You are that universe, experiencing itself from a particular point of view. Imagine where you'll be 6 months from now if you start living from this place. If you stop seeing yourself as a small, limited creature in a cold, indifferent universe and start seeing yourself as a multidimensional being in a reality of infinite possibility. Imagine what you could create, what you could become. You don't have to stay stuck in the version of reality you were born into. You have the map now. You have the understanding. The dimensions are there, waiting for you to explore them, waiting for you to remember who you really are. If this shifted something in you, drop a comment with the word dimensions. I read every single one, and I want to know where this journey took you.